Hi, welcome to part 12 of Electromagnetic Induction. In this video, I shall explain the solution of question 6.12 on page 231 of NCERT Physics textbook part 1. This is from chapter 6, Electromagnetic Induction. In this question, they have spoken that there is a square loop of side 12 cm with its sides parallel to x and y axis and is moved with a velocity of 8 cm per second in the positive x direction in an environment containing a magnetic field in the positive z direction. The field is neither uniform in space nor constant in time. It has a gradient of 10 to the power minus 3 Tesla per centimeter along the negative x direction. That is, it increases by 10 to the power minus 3 Tesla per centimeter, which is also equal to 10 to the power minus 1 Tesla per meter, as one moves in the negative x direction, and it is decreasing in time at the rate of 10 to the power minus 3 Tesla per second. So we need to find out the direction and magnitude of induced current in the loop if the resistance is equal to 4.5 milliohms. So there is a square loop of side 12 cm whose sides are parallel to the x and y axis. I am analyzing the question once again. So there is a square loop of side 12 cm whose sides are parallel to both x and y axis, and it's kept in a magnetic field which is in the positive z direction. This magnetic field is neither uniform in space nor constant in time. So, this magnetic field changes with space and is also changing with time. Since this magnetic field increases in the negative x direction, so in the positive x direction, dB dx will decrease. So it's given by minus 10 to the power minus 1 Tesla per meter. dB dt is also decreasing with time at the rate of 10 to the power minus 3 Tesla per second. So as the loop is moved towards the positive x direction, flux d phi dt due to dB dx is decreasing, and flux due to dB dt is also decreasing. So d phi dt is negative both for dB dx and for dB dt. Since there is change of flux, there will be induced EMF. This induced EMF will give rise to induced current because it is a closed loop. So d phi dt is not only due to dB dx but also due to dB dt. So we need to know what is this d phi dt. What is the value of d phi dt to know what is the magnitude of induced EMF. EMF is equal to minus d phi dt. So let's find out what is d phi dt due to dB dx and d phi dt due to dB dt. So d phi dt is equal to area of the loop remains constant at as it moves towards the positive x direction. So d phi dt can be written as a dB dt. A is given by 0.12 into 0.12 into dB dt is 10 to the power minus 3 Tesla per second. So this works out to be, this dB dt is minus because it decreases with time. So it works out to be minus 144 into 10 to the power minus 7 Webers per second. So this is d phi dt due to dB dt. Now let's find out what is d phi dt due to dB dx. D phi dt is a dB dt, which is also written as, which can also be written as a dB dx into dx dt. This is nothing but velocity and this is given. So we can put the value of a as 0.12 into 0.12 into minus 10 to the power minus 1 Tesla per meter into 0.08. So this becomes equal to 1 minus 1152 into 10 to the power minus 7 Webers per second. So we found out what was d phi dt due to dB dt, and we have also found out what is d phi dt due to dB dx. So we can add up d phi dt due to both dB dx and dB dt as equal to minus 144 plus minus 1152. The whole thing is 10 to the power minus 7. So this becomes equal to minus 1296 into 10 to the power minus 7 Webers per second. So this induced EMF is equal to minus d phi dt, so which is equal to 1296 into 10 to the power minus 7 volts. So induced current will be induced EMF by R. So induced EMF being equal to 1296 into 10 to the power minus 7 by resistance is given as 4.5 milliohms. So 10 to the power minus 3. This is the value of induced current, which is equal to 2.88 into 10 to the power minus 2 amperes. Now let's see what would be the direction of induced current. So it's given that the square loop has its sides parallel to x and y axis, and the magnetic field is in the positive z direction. So as the loop moves in the positive x direction, d phi dt is due to both dB dx and dB dt. Change of magnetic field due in space and change of magnetic field due to time. So since the magnetic field decreases in the positive x direction and the magnetic field decreases with time, the flux lines will decrease in time through the loop. So there is a decrease in flux out. both due to dBdx and dBdt. So there is a decrease in flux out through the loop. So for an observer who stands, who sees the loop moving to the right, for him the flux out is decreasing. So there has to be an increase in flux out to counter this decrease in flux out. So there has to be a north polarity induced in the coil, as a result of which the current should be in the anti-clockwise direction. In case of any clarifications, you can always log on to www.olympiadtester.com/mentor. Thank you.